Okay, welcome to the third and final video all about power functions. Um, and this one really is just about solving equations that have kind of different looking exponents in them. Um, let's check out the first one. 5g to the negative 2 equals 25. It says solve the equation. When it says solve the equations, in this case we want to know what g is. We want to end with something that looks like this. G equals this number. That's our goal. So we really need to get g by itself and hopefully with an exponent of 1. First thing to do is divide both sides by 5. Get rid of that 5. So then we can say g to the negative 2 equals 25 divided by 5 is 5. We don't want to know what g to the negative 2 is. We want to know what g is. So we got to somehow make this into a 1. And I remember back that with exponent rules, if you have a power to a power, you multiply those powers to simplify them. So is there something that we could multiply negative 2 by to create a 1? Negative 2 times something equals 1. How about negative 1/2? So g to the negative 2 to the negative 1/2, this right here would be negative 2 times negative 1/2 is a positive 1. So that's awesome. That would make a g to the 1 on the left side. You can't just randomly raise a side of an equation to a power, though. You have to do the same thing to both sides. So if we raise this to the negative 1/2 power, we have to raise this to the negative 1/2 power. And so that's fine, we'll deal with that. 5 to the negative 1/2. Okay, a negative means that this would look like 1 over 5 to the 1/2. Looking a little better. G to the 1 is just g. So g equals 1/5 to the 1/2 power. Taking something to the 1/2 power, at this point we really could just put this into our calculator and get some decimal number for it. But let's just talk through the logic of it. 1/5 to the 1/2 power would be the square root of 1/5. That's what a 1/2 power means. It's a square root. This would equal 1 over the square root of 5, because it's the square root of 1 over the square root of 5, and the square root of 1 is just 1. Traditionally, you don't leave a square root in a denominator, so we do something called rationalizing the denominator. You've probably seen before. Square root of 5 times square root of 5 is 5. So this is what g is. Let's see what our calculator says about that. Okay, say that right here we had just typed in 1 divided by 5 to the 1 divided by 2 power. So from right here, it tells me that the answer is g would be 0.4472 if we wanted 4 decimal points. Okay, let's do this guy also and see if we get the same thing. Square root of 5 no. Square root of 5, no. I don't know how to get out of that. We'll just say equals divided by 5. And so this number also is 0.4472. This looks like the right number for what g is. Okay, so in WebAssign, you could either type in this guy or this guy. The important thing, probably the hardest step in this one, is realizing that to get rid of this negative 2 power, we needed to multiply by negative 1/2. Okay, let's try the next one and see if we can solve this one. 1.5 m to the 0.65 equals 25. We really want to know what m is. We don't care what m to the 0.65 is. We want to know what m is. So here again, the first thing to do is we'll divide by 1.5 both sides. So m to the 0.65 will equal 25 divided by 1.5. Is this. Now we got to figure out, we don't want this power. We want it to be m to the power of 1. what would you multiply, or what power would you raise this to create a 1 here? Essentially, we want 0.65 times something to equal 1. That's what a power to a power you would have to do. Well, the thing I can think of is its reciprocal, and that's always going to work. So if I took this to the 1 over 0.65 power, and of course I have to do it over here also, that should give me power to a power, multiply these, it would just be m to the 1. So m to the 1, or m, is going to equal this guy right here, and I cannot do that in my head for sure. So I'll pick up the 16.667, raise it to the, be sure to use parentheses, of course, with your powers, and m equals 75.817. I'm just going to do a little double check here, just to make sure I didn't type anything in wrong. So let's see here, 1.5 times what I found was the answer, 75.817, raised to the 0.65. When I hit enter, I really hope it's 25. Yep, it is. Round it up. Good. Okay, so this next one is a little bit new. 2, and then we've got all these numbers, 4, 7, 25. So this is the 4th root of t to the 7th. And we want to solve this equation, so we want to know what t is. The first thing we'll do is get rid of the 2. So the 4th root of t to the 7 equals 25 divided by 2 is 12.5. Now, all of these guys, how do we get rid of this? I think of this as a power. T to the 7th, what would the 4th root of t to the 7th look like if I was just writing it as a power? T to the 7th, how do I write 4th roots as powers? It's to the 1/4 power. This is the 4th root of t to the 7th. I do not have to write the same thing on the right side because it's something that was already there. I'm just rewriting it as an exponent instead of as a root. Okay, so now what I have is t, let's see, a power to a power I multiply. So 7 times 1/4 is t to the 7/4 equals 12.5. And again, I really care about just what t is, or t to the 1st power. What power could I raise this to over here to get the power on t to be 1? In the past, we've always been multiplying or raising that power, or that variable power, to the reciprocal of the power, and it works here too. We raise this to the 4/7 power. Here we do have to do both sides because we're just totally introducing this new thing. T to the 7/4 to the 4/7. You would multiply these powers together, and when you multiply them, you'll get 28 over 28. That's 1. So you have t to the 1 equals whatever this is, 12.5 to the 4/7. So t to the 1 is just t. And I'll do 12.5 to the 4/7. Well, I missed a parentheses in there. I need to go back and get that. 4.2345 is what I think t should be. I'm going to do a quick double check. Okay. 2 times, we're going to call this 4.2345 raised to the parentheses 7 divided by 4. And here I really hope it's 25. And it is. Good. Good job, guys. Okay, last one we're going to do together is this one. This is going to be pretty much like that b up there. Divide both sides by 4.25, and we get v to the 0.38 equals 15 divided by 4.25. So that's 3.5294. Okay, I don't care what v to the 0.38 is. I really need to know what v is. So I'm going to raise it to some power. And what's been working is if I raise it to the reciprocal of this number here, that will create a v to the 1. So I raise this to 1 over 0.38. Same story over here. Got to do the same thing to the left and the right because I'm just totally introducing this new thing. I get v to the 1, which equals v, will equal this number. 3.5294 to the 1 divided by 0.38 power. So v is 27.626. All right, you have everything you need to finish WebAssign 5.2 at this point. Remember, we did do power regressions in class together, and remember on Desmos, if when you're given the option, okay, so this has nothing to do with that problem. Power regression on Desmos, make sure you check log mode, and then you'll get the same numbers that are used in WebAssign. It's just two different ways to do a regression, and the log mode is what we want to use. All right, hope you have a great day, and we'll talk soon.